In this video, I want to show you how we can use sum and difference formulas for doing this tricky question. If alpha plus beta plus gamma equals pi, show that tangent alpha plus tangent of beta plus tangent of gamma equals tangent of alpha times tangent beta times tangent gamma. I will show you two different methods for doing this question. Method 1. First, we start from this relation. The sum of alpha and beta and gamma is pi. From this relation, alpha plus beta equals pi minus gamma. We subtract gamma from both sides, and so alpha plus beta is pi minus gamma. We want to derive this relation. And as you can see in this relation, we have tangent everywhere. So for that reason, now we take tangent from both sides of this relation. If we take tangent from both sides, we have tangent of alpha plus beta equals tangent of pi minus gamma. Now here, for the left side and for the right side, we can use the sum and difference formula for tangent. Based on the sum formula for tangent, tangent of alpha plus beta is equal to, if you remember, is equal to tangent of alpha plus tangent of beta all over 1 minus tangent of alpha tangent of beta. This is the formula for the sum of the angles for tangent. But in the other side, we have minus here. When there is a minus, the difference is that here is minus, here is plus. We use same formula also for the other side, but the difference is that it is minus. By using the formula for minus for the other side, this equals tangent of pi minus tangent of gamma all over 1 plus tangent of pi tangent of gamma. Tangent of pi is 0. If you remember the unit circle, pi is here and tangent of pi is 0. Tangent of pi is sine of pi over cosine of pi. Sine of pi is 0. Cosine of pi is -1 at this point. The x value, which is cosine, is -1. The y value is 0, which is sine. 0 over -1 is 0. So tangent of pi is 0. So if we simplify the right side and we rewrite the left side, we have tangent of alpha plus tangent of beta all over 1 minus tangent alpha tangent beta equals negative tangent of gamma. Attention, tangent of pi is 0, so this is 0. This is also 0 because 0 times tangent gamma is 0, and in denominator we have only 1, so all over 1. And we don't really need to write this 1 here. Now here, if we do a simple cross multiplication, if we multiply this denominator by numerator and if we multiply this denominator by this numerator, if we do a cross multiplication here, we can derive this relation easily. Let me show you how we can get this relation. By multiplying 1 in the numerator, we have 1 times tangent alpha is tangent alpha plus tangent beta. In the other side, if we multiply 1 by negative tangent, we have negative tangent gamma minus tangent alpha tangent beta times by minus tangent gamma would be plus. So we have plus tangent alpha tangent beta tangent gamma. And now here if we simply move this term from here to the left side, or in another word, if we add tangent gamma to both sides, then we get to this relation. So I'm not going to rewrite this again. Here I erase this from here and I move this to the other side, and we get the desired result. So we have tangent alpha plus tangent beta plus tangent of gamma equals tangent alpha, tangent beta, tangent gamma. Now let me show you another method for proving this relation. So in another way, we want to prove that if alpha plus beta plus gamma equals pi, then tangent alpha plus tangent beta plus tangent gamma equals tangent alpha tangent beta tangent gamma. Here we start the solution in a completely different way. Tangent alpha, based on there, we start from this side, and during the solution we use this relation and we try to get from this to the other side. This is completely another method for proving this relation. Based on the quotient identities, tangent alpha can be written as sine of alpha over cosine alpha. Tangent beta is sine beta over cosine beta, and tangent gamma is sine of gamma over cosine of gamma. Here we have three fractions and we want to add them to each other. What we have to do here? Of course we have to do a common denominator, and the common denominator is cosine of alpha, cosine of beta, cosine of gamma. What would be the numerator? The numerator for this would be sine of alpha times by these denominators. So we have sine alpha, cosine beta, cosine gamma. Then we have sine of beta times by these two. So we have sine of beta times cosine alpha, cosine gamma. And finally we have sine of gamma times by these two, which is cosine alpha, cosine beta. Now here, if you pay attention, between this term and this term, cosine gamma is a common factor. From only these two terms, we factor cosine of gamma. Let's see what happens if we do this. So here, we again write the denominator, cosine alpha, cosine beta, cosine gamma, and from the first two terms we factor cosine of gamma. By factoring cosine of gamma, then we have sine alpha, cosine beta, plus sine beta, cosine of alpha. And don't forget the last term, sine of gamma times by cosine alpha, cosine beta. Now look at this expression here. This should look familiar for you. Sine of alpha cosine beta plus sine of beta cosine alpha. This should remind you this relation. The expression inside the bracket is basically sine of alpha plus beta. If you remember the sum formula for two angles for sine, you remember that sine of alpha plus beta is exactly this. So let me erase the expression, or no, let me rewrite this again to show you all the steps in detail. So we have cosine gamma times sine of alpha plus beta. This expression is sine of alpha plus beta. And then we have plus sine of gamma, cosine alpha, cosine beta, all over cosine alpha, cosine beta, cosine gamma. This is gamma. So far in this solution, if you pay attention, we never use this condition that we had for alpha, beta and gamma. This is the first time that we want to use this condition. Of course, we have to use that condition during our solution, because under this condition, this is true. Alpha plus beta plus gamma is pi. So, instead of alpha plus beta here, we can substitute alpha plus beta with pi minus gamma. From this relation, alpha plus beta is pi minus gamma. So here we can substitute alpha plus beta here with pi minus gamma. Let me do this here, because I don't want to write all of this again. So here, don't forget, we substituted alpha plus beta with pi minus gamma, because from this relation we know that alpha plus beta is pi minus gamma. So we can do this because we have that condition for alpha plus beta plus gamma. Now let's open this sign with the formula for difference of angles. So let me show you what happens if we do this here. We have cosine of gamma times by, what is the formula for sine of the difference of two angles? Sine of pi minus gamma. Sine of pi minus gamma from the difference of angles formula is sine of pi cosine of gamma minus cosine pi sine of gamma. This is the formula that we have for difference of the angles. And we rewrite everything else. Sine gamma, cosine alpha, cosine beta, all over cosine alpha, cosine beta, cosine gamma. As you can see, this method is more complicated than the previous method. The first method was very straightforward and easier, but this is another way. Here, now if you pay attention, sine of pi is 0. So this term is 0 because sine of pi is 0. Cosine of pi is negative 1 times negative would be 1. 1 times sine gamma is sine of gamma. So sine of pi minus gamma is sine of gamma. Let me explain this again. This term is 0 because sine of pi is 0. Cosine of pi negative 1 times negative positive 1 times sine of gamma is sine of gamma. So we can erase everything that here we have, and we can write instead of all of this only sine of gamma. Now here at this step, look at this term and this term. Sine of gamma is common between these two terms. So we can write this in the form of, so we can write this in this form. Sine gamma times by cosine gamma plus cosine alpha cosine beta, all over cosine alpha cosine beta cosine gamma. From this to this, we factored sine of gamma. From the first term we have cosine gamma, from the second term we have cosine alpha cosine beta. Now here at this step, again we use the condition that here we have. Alpha plus beta plus gamma is pi. So from this relation, gamma is pi minus alpha minus beta. If we move this to the other side, gamma is pi minus alpha minus beta. So we have a beta here. So here I want to substitute this gamma with pi minus alpha minus beta. We substitute the angle gamma with pi minus alpha minus beta. And we keep cosine alpha, cosine beta here. All over cosine alpha, cosine beta, cosine gamma. Now let me simplify this term here for you. Cosine of, let me simplify it here because I don't want to repeat all the expression again and again. Cosine of pi minus alpha minus beta is basically cosine of pi minus alpha plus beta. From these two we factor a negative. Now let's use the difference angle identity for cosine. Let me remind you, cosine of A minus B is cosine A. Cosine B plus sine A sine B. This is the formula that we have. If we use this relation for A minus B, all of this angle, the pi is A, all of this angle is B. If we use this formula, then we have cosine of pi, cosine of alpha plus beta plus sine of pi, sine of alpha plus beta. Cosine of pi is -1, sine of pi is 0. So this term is 0. This is gone. This term is gone, so let me erase it. And this equals negative cosine of alpha plus beta. So here I showed you that this cosine is negative cosine alpha plus beta. So let me erase it from here and substitute its simplified version here. Cosine of pi minus alpha minus beta is minus cosine of alpha plus beta. So we have sine of gamma times by. Now for this, for cosine of alpha plus beta, if you remember cosine of alpha plus beta based on the sum formula, sum of angles formula for cosine, this equals cosine of alpha, cosine of beta minus sine of alpha, sine of beta. This is the formula that we have for cosine of alpha plus beta. But don't forget we have a negative here. So we have to multiply this by a negative and we have to multiply this also by a negative. If we do this here, we have negative cosine alpha, cosine beta plus sine of alpha, sine beta plus cosine alpha, cosine beta. Don't forget this term. All over. Now if you look at the expression in the bracket, you can see that negative cosine alpha, cosine beta with cosine alpha, cosine beta cancels and we have only sine alpha, sine beta in the bracket. So what we have in the numerator, if you pay attention, in numerator we have sine of alpha, sine of beta, sine of gamma, sine of gamma, sine of alpha, sine of beta. And we have multiplied them by each other. This is what we have in the numerator. What we have in the denominator, cosine of alpha, cosine of beta, cosine of gamma. Now if we separate sine over cosine, sine of alpha over cosine alpha is tangent alpha. Then we have tangent beta and finally we have tangent gamma. So this is the second method for proving this relation here. But of course the first method is more straightforward and easier to understand. But I try to show you two different methods for proving this relation, this identity based on the condition. I hope you like this video. If you like this video, please subscribe in my channel and see you in the next videos.